Hello everyone, this is Vijay. Welcome to the first part of video working principle of transformer. So before diving into transformer, let's understand the basic laws that are required in order to gain complete understanding of transformer. So the first one is Faraday's laws of electromagnetic field, of electromagnetic induction, and second one we got Lenz law. Alright, so let's discuss each part. So first one, Faraday's law. So change in magnetic field linked to a coil. Let's say we got a coil here, and if I see my magnetic field or flux is towards up, so for change in magnetic field or flux, a EMF is induced across the coil. So this is first law, and the second law states that EMF, let's say I got terminals A, terminals B, the magnitude of VAB, that EMF is equals to the rate of change of that flux. So this is what Faraday's law states, but we need to know what is the direction, or we can say the polarity of this induced EMF. So for that we require Lenz law. So before going into Lenz law, let's understand, let's revise some quick topic, which is the right hand thumb rule. So when current flows in this direction for a coil, this results in a upward flux phi. Let's say if we have a reluctance of this coil, or reluctance of this space is R, or this is reluctance of the space, and phi is equals to I. If we got n coils, n turns, we get n. So from right hand thumb rule, this is for anti-clockwise current direction. So for anti-clockwise direction of current, we get upward flux, and for clockwise direction, of current, we get a downward flux. So let's remember this one, and from here let's proceed to Lenz law. Now what does Lenz law states? So Lenz law in electromagnetism states that an induced electric current flows in a direction such that the current opposes the change that induced it. What does it mean? Let's connect a resistor here. So if we have a resistor and VAB is our induced EMF, and now we are trying to find the direction of this induced EMF. So from what is Lenz law stating is, if my flux, the upward flux, if it is increasing, that means I have some flux here, and if it is increasing, so the current induced should oppose this increase. So my current induced should induce flux in the downwards direction, so that my increase in flux towards upward, that is opposed. So for that to happen, so current direction should be downward. So when phi is increasing, in our direction, upward direction, so for this polarity of VAB, we have to check whether VAB is positive or negative. So our current direction should be in this way, so that flux will be downward, and this increase in flux towards upward is opposed. So for current direction to be in this way, our VAB should be negative, so that my current direction can be in this way. So VAB should be negative. When phi is increasing, when phi is decreasing, in the upward direction only. So in the upward direction I have some flux, and now it is decreasing. So when it is decreasing, that means it has some rate of change of flux, so some voltage is induced. So that voltage direction should oppose this change, should oppose this d phi by dt. The cause, whatever it is, the EMF, whatever the cause of that induced EMF, that induced EMF should oppose that cause. So my current should be in this direction, such that flux is upwards, and that decrease in flux is opposed. So when phi is decreasing, my VAB should be positive. When it is positive, my current flows in this direction, when VAB is positive, and this direction will satisfy this direction. Yeah. So from Lenz law, here we can state that VAB is equals to minus d phi over dt. This minus and this VAB, this all are valid for this representation. So for A and B of this coil, and the coil is in x-axis or xy plane, and my phi direction is upwards. So for all these conditions, this formula is valid. So through Faraday's law and Lenz law, we are getting this formula. So now we derived this. So if you want to move ahead, so the discussion we shall do is for a sinusoidal. So just remember this thing, or else I'll draw it again. So I got VAB, I got flux. Now what I wanna do is, so let's say I got phi equals to sine omega t. So from the formula, I'll get VAB equals to minus omega cos omega t. Let's understand whether what we have discussed is actually applicable or is actually happening as we discussed or not. So let's say we got a sine omega t phi. Now VAB will be minus omega cos omega t. So if I start from here, and then here, and here to the negative peak. Okay, so when my phi is increasing, when phi is increasing, my VAB is negative, so the direction is fine. So when my phi is decreasing from positive peak to negative peak, my VAB is positive, and its magnitude is always equals to uh, is equals to minus, or including the direction, minus d phi over dt. So when phi is increasing, VAB is positive, sorry, negative, and when it is decreasing, VAB is positive. Now if we draw phasor, so if you can observe here, so if this is a, I can say, 360 degrees span or period, so phi has reached its peak, positive peak, at 90 degrees, and after 90 degrees of delay, VAB reaches its peak, right? So what we say? We say VAB is lagging phi by 90 degrees. So let's draw phasors. If this is my phi, this will be my VAB. So I hope you understood the flux and induced voltage relation. So this is very important if you want to understand the principle of transformer, working principle of transformer. So for this part of the video I will end it here, and in the next part we shall apply these concepts, and we shall try to understand how transformer is working and how it is able to transmit energy. Okay, thank you. If you got any doubts here, you can comment in the comment box, or and if you want any clear explanation of any particular doubt, do comment in the video, and I'll try to make a video. Thank you.